Scattered throughout West Virginia are companies manufacturing goods made out of plastics, from eyeglass lenses to food packaging to party tents. And there's plenty of research underway in this burgeoning industry. Erica Peterson has tonight's Mountain State Science Report from the Kanawha Valley, where scientists are working to develop a new type of plastic.
33 of West Virginia's 55 counties have some type of plastics manufacturing. Many of the companies are clustered in Jackson, Mason, and Wood counties. Those three counties have been christened the Polymer Alliance Zone and are banded together by a membership organization. The group's president, Karen Facemeyer, who is also a state senator, says the industry generates more than $2 billion a year in economic activity.
So if the industry left today, would you notice it? Yes, you would notice it. Just from unemployment figures, the amount of taxes, the state would take a major hit to the budget because over 178 million is paid in state taxes each year through the polymer companies.
So what exactly is a polymer? Poly means many, and polymer is an umbrella term for a molecule with repeating structural units. The category encompasses a variety of natural and synthetic materials like rubber, cellulose, nylon, and plastic. So all plastics are polymers, but not all polymers are plastics. Facemeyer's organization advocates for 75 of West Virginia's polymer companies. One of its members is Richmond Optics. For the past 23 years, Homer Richmond has owned his building in Charleston, where he manufactures eyeglass lenses. Richmond says lenses are often made of plastic. Glass is clearer but breakable. Oftentimes, people want lenses made out of a type of plastic called polycarbonate. It's very strong, but has some issues with clarity.
Get distortion the further out you go. Dead center, it's okay, but when you start looking out toward the edges of the lens, you get the distortion.
Polycarbonate isn't just used for eyeglass lenses. It's found in everything from shopping cart wheels to car parts to airplane equipment. It has two major benefits. It's nearly unbreakable, and in some forms, it's pretty clear. But polycarbonate isn't perfect, at least as far as eyeglass lenses are concerned. Richmond says if there was a material that was equally strong but clearer, he could see a market for it.
It'd be a tremendous thing, I think. I think it would be great because the public could use it.
Across the Kanawha River from Richmond Optics, Richard Jerkin is working on that very problem. What Jerkin's holding isn't just an ordinary piece of plastic. It's extra strong and extra clear. He calls it Visiplex, and it's a type of polyurethane he has invented.
We knew about polycarbonate. We knew it was out there. We knew it's a standard in the industry for impact-resistant plastic. And we felt that if we could properly formulate this new urethane, that we could compete with that material and or maybe even be better.
Jerkin is the president of Polyplex Llc. His company operates out of the South Charleston Technology Park as part of the Mid-Atlantic Technology Research and Innovation Center, or MATRIC. MATRIC is a nonprofit that fosters and commercializes scientific research and development. When it was formed 4 years ago, Polyplex was their first commercial spin-off. In their lab in Building 740, Jerkin and his assistant, Mike Walker, are mixing up some of their plastic.
Okay, we're adding the A side to the B side.
He's got it in a mixer. He's going to place it in this high-intensity, high-shear mixing system.
Walker pours the liquid into a mold.
The curing process now effectively starts,
where it'll sit for 30 minutes.
When that half an hour is over, we will demold that material from that plaque and from that mold, and what you will see is a piece of polymer that will look very much like this. This is a piece that is 6 inches by 6 inches by 1/8 inch thick, and it is very, very typical of the kind of plaques of plastic that we make that will allow us eventually to look at physical properties and determine how well the plastic now is going to perform.
And from what Jerkin and Walker can tell, it performs well. They've run Visiplex through a battery of tests. Using a machine called a durometer, Jerkin measures the hardness of Visiplex. It's an 85 on the D scale. The scale goes up to 100, and the higher the number, the harder the material. Visiplex and polycarbonate are both about the same hardness. Then there are the less scientific-sounding tests. Visiplex is routinely hit with projectiles, including bullets. The material doesn't shatter and actually catches the bullet.
This shows what happens when you actually shoot the plaque with a .22 long rifle bullet. This was shot out in the woods here in West Virginia, and you can see again virtually the same behavior.
So, Jerkin's tests indicate that Visiplex and polycarbonate are comparably hard and unbreakable. But it's in two other categories, clarity and solvent resistance, where his polyurethane pulls ahead. One of polycarbonate's main shortcomings is that it dissolves when it comes into contact with certain chemicals, like acetone. This is a problem because acetone is a common household product found in nail polish remover. But Visiplex doesn't react the same way.
I put more acetone, more acetone, more acetone, more acetone, same stress level, virtually nothing happens.
And it turns out Visiplex is also much clearer than polycarbonate. Originally, Jerkin was focusing on developing the polymer for high-performance face and window shields. Those are still priorities, but now he sees another potential use.
When we got into looking at other application areas, we started talking about the ophthalmic world. And all of the development effort that we had done led us to understand just how clear our material was. And what we learned was our material is in fact almost 100% clearer than polycarbonate, which everybody understands is already a clear polymer. So we had this really high clarity.
The next step for Jerkin's Visiplex is customer trials to see if the material performs as well in the real world as it does in the laboratory. These trials started late last year and are expected to last into the spring. Visiplex, invented in West Virginia, could potentially be the material of the next generation of eyeglass lenses or high-performance shields. For West Virginia Public Broadcasting, I'm Erica Peterson in Charleston.
Support for the Mountain State Science Series comes from the National Science Foundation's experimental program to stimulate competitive research, investing in West Virginia's future by building infrastructure for scientific research. On the web at wvresearch.org.